Hi, how are you? I would like to talk about task 9.1, and for task 9.1, 1 and 2 are pretty self-explanatory, so I'm gonna skip those two and go straight to DFS and BFS. So the question is here, and for DFS, we'll have for example, if you start from A, for DFS, because it's depth first search, it'll go through all the possible routes until it is reached the end. For example, it will be B, F, I, N, E, J, K, O, C, L, D, G, M, and because it haven't reached H, you'll go back to L and then search to H, and therefore going through all the nodes and vertices and edges. And for BFS, and that will go all the surrounding edges first. So for example, if I start from A, and that will go to B and go back, and then I and the N and the E, and then go K, I'll go C, and then it'll pick a node. For example, it'll pick a B, it'll pick B, and then it'll go F and H and go back, and then go C. It will be O, M, L, and etc. And that is represented here with the diagram. Also, you asked about sorry if I can't pronounce the name correctly, is Diderot's algorithm, and that is the example I believe you used. So I'm going to explain it here as well. For example, if we start from A and then we want to reach the point F, we'll first decide which one to go. This is a weighted and directed graph. Well, from A to B is 1, from A to D is 2, so therefore we'll pick the shorter and the less weighted one, right? So that'll be from A to B, and that'll be updated as 1 here. And then from B to C, that's the only direction we can go, so that's 2. And from C to F, that's the only direction we can go as well, so that's all together, that'll be 3. But that's not how it works. We have to visit every single node as well. So from A to D, if this one's 1 as well, for example, if they both have the same weight, then it will just choose by the alphabetical order, or whatever the order is determined while we write the algorithm out. But since it's not the same way, so that it doesn't really matter. From A to D, then that will be updated as 2. And from D to E and C, there's 2 options. From A to E, then that will just be 4. 2 plus 2, and then from A to C, that'll also be 4. But if we want to choose it, let's say we want to go from A to C, then obviously we'll choose the shorter path that'll go through B instead of going through D. And from here we have 2 other scenarios for if we want to go from A to E. Obviously, we want to choose from A, D, E, and that'll be 4 rather than A, B, C, and then E, because that'll be 2 plus the 4, and that'll be 6. Obviously, we want to choose the shorter one, so that'll be E. And from E to F, we'll have 4 plus 5, and that'll be 9. And obviously, that is a lot more larger than A to B to C to E to F, which is only considered of 3. And believe you also asked me about the running complexity of both the DFS tree and BFS. Both of them have the big O running complexity of V plus E, which is what is represented. V as in number of vertices plus number of edges. Although both of them, I'll start again. But that is only given as a adjacency list. When we have adjacency matrix, I believe this matrix, I believe it'll be big O to the V power of 2, because then we'll have then that'll be a 2-dimensional rather than just a 1-dimensional list. Also with oh yeah, so although both of them have the same running time complexity, in certain scenarios one of them can go faster, because with depth first search, if the condition of the element that we're looking for is all the way towards the end of a tree, for example something from here to here, then obviously that first tree will be a much better choice, because it will go through all the nodes until it reaches the end first, and therefore DFS will work faster. But if the for example, if the item we're looking for is somewhere around here or here, then obviously that'll be faster if we use BFS, because it will search through all the nodes close to it. For example, it will search through this one if unlucky, and then search through this one, and that will be much faster comparing to DFS.